Welcome back, deep divers. Ready for another fascinating journey into the unknown?
Always.
Today we're diving into something you might not have even realized existed: polar vortices on the sun.
Oh, cool.
It seems our very own star has these swirling formations just like Earth does, but with a fascinating magnetic twist. So get ready for some solar shenanigans. Our source for this deep dive is some amazing new research from the scientists at NCIR, the National Center for Atmospheric Research.
Yeah.
They've been using some super sophisticated computer models to study these mysterious solar phenomena, and we're going to break down their findings. But first, for those who might not be familiar, what exactly is a polar vortex?
Well, in the simplest terms, a polar vortex is this spinning, swirling formation in fluids, like air or water, that forms around a rotating body.
Right.
They're kind of like giant whirlpools at the poles, and they happen because of something called the Coriolis effect. It's this weird thing where the Earth's rotation makes fluids curve as they move.
Oh, I remember learning about that in science class. So these vortices are pretty common throughout our solar system.
Oh, yeah. They're actually found on most planets, but each one is unique in its own way.
Right.
You take Jupiter, for example. It's got this whole cluster of vortices swirling around East Pole. There's like a crazy octet of whirlpools up there. And then there's Saturn's North Pole, which has this mind-blowing hexagon-shaped vortex.
The hexagon. Wait, nature really likes to get creative with shapes, doesn't it?
You can say that again.
So what do those differences in shape tell us about the planets?
Well, by studying how these vortices behave and what they look like, scientists can actually learn a lot about what's going on in the atmospheres of those planets. But when it comes to the sun, well, things get a little more complicated.
Oh, why is that?
See, the sun's outer layer is made up of something called plasma. And that's basically a superheated gas so hot that the atoms have been stripped of some of their electrons.
What's fascinating here is that this plasma acts like a magnetic fluid.
Meaning that the sun's vortices are shaped by magnetism, which makes them truly one of a kind in our solar system.
That is wild. But hold on, we've never actually seen the sun's poles directly, right?
Yes.
I mean, all our observations of the sun are from the side facing Earth. So how in the world did scientists figure out these solar vortices might exist in the first place?
That's a great question. And this is where those amazing scientists at NCIR come in. They've been using some really advanced computer models to simulate how the sun's magnetic fields might behave near its poles. What they discovered is that a ring of these vortices actually forms around 55 degrees latitude on the sun.
55 degrees.
That's kind of like the equivalent of the Arctic Circle here on Earth.
Okay, I see.
And the really fascinating part is that these vortices seem to be connected to the sun's 11-year solar cycle. The regular ebb and flow of solar activity.
Yeah. So, to be clear, we have this ring of solar vortices, like tiny solar hurricanes, swirling around the sun's poles, and their behavior actually changes with that 11-year cycle.
Exactly. It's like a solar vortex ballet, all choreographed by the sun's magnetism.
Okay, now I'm really intrigued.
And the craziest part,
What's that?
as that solar cycle progresses, these vortices actually start moving closer to the poles.
Whoa, so they're not just spinning in place.
Nope, they're moving, and get this. They shed some vortices as they go,
Wow.
until eventually only 2 vortices are left, one at each pole.
Okay.
And then, just as the sun reaches its peak activity, that solar maximum, they vanish completely.
So they appear, they dance around, they shed, they gather at the poles, and then poof, gone.
Exactly. It's a wild ride.
It really is. But tell me, what does all this swirling and shedding and disappearing tell us about the sun? Is it just a cool visual phenomenon, or is there something more to it?
Oh, there's definitely something more. You see, this discovery could be a game changer in terms of helping us predict the strength of future solar cycles.
Wait, seriously?
Yeah. And you know what that means for us back here on Earth?
What?
It could change the way we protect ourselves.
Protect ourselves how?
From those massive solar storms that can disrupt all our technology.
Huh.
So those tiny swirls could actually help us forecast space weather.
This is getting really good. Can you tell me more about that connection?
Of course. It all comes down to the sun's magnetic field, really, and something we call the rush to the poles.
Rush to the poles, okay.
Yeah, think of it like 2 magnets kind of pushing against each other.
Yeah.
Eventually one magnet's going to overpower the other one, and it causes a flip. So during this rush to the poles, what we see is a new magnetic field, opposite in polarity to the current one, pops up around 55 degrees latitude, and it starts traveling towards the poles before they flip at the solar cycle maximum.
Okay.
by measuring the strength of this emerging magnetic field during this rush. You know, scientists believe we can get a better sense of just how strong that next solar cycle is going to be.
So it's almost like looking for clues, like in the sun's magnetic fingerprint to see what it's going to do next.
Yeah, exactly.
Okay, so the stronger that magnetic field is during that rush, the more intense the next solar cycle is going to be. And I'm assuming the more likely we are to experience those disruptions here on Earth.
That's the general idea, yeah.
Okay.
But you got to keep in mind, this is still a very active area of research. You know, there's still a lot more we need to learn before we can, like, make really accurate predictions about, solar activity and all that.
Right, but even if we can't, like, perfectly predict them yet, just knowing that a solar storm's coming would be incredibly valuable.
Well, absolutely. Imagine being able to prepare for a major solar storm, like weeks or even months in advance.
Oh, wow.
You could take steps to protect our power grids, our satellites, our communication systems, really minimize that disruption to, like, our everyday lives.
Yeah, that would be a game changer.
It would.
So it seems like we have a lot riding on these tiny swirling vortices millions of miles away, Who knew that they held the key to understanding and potentially predicting such powerful events?
It's true. And it's a humbling reminder that we are, deeply connected to the sun and its activity. The more we learn about those connections, the better equipped we'll be to, navigate those challenges and opportunities that it presents.
Absolutely. And speaking of challenges, we've talked a lot about what we are learning. But what are some of the biggest challenges that researchers are facing when it comes to really understanding these solar vortices?
Well, I think one of the biggest hurdles, really, is simply that we can't directly observe those sun's poles.
Right.
We have to rely on these really sophisticated computer models and spacecraft like the Solar Orbiter to even get a glimpse of what's happening up there.
So it's almost like trying to solve a puzzle with some of the pieces missing.
Exactly. And another challenge is just that the sun is this incredibly complex and dynamic system. There are so many factors at play that it's hard to, like, isolate the specific role that these solar vortices are playing in, Things like solar flares and coronal mass ejections, those big bursts of energy that can disrupt our technology.
Yeah, right. It sounds like there's still so much to learn.
Oh, definitely. There are so many unanswered questions out there, Like, for example, we're still not entirely sure how these vortices even form.
Mm-hmm.
We see them in the computer models, but we need more data to really grasp, like, the underlying physics that drive their creation.
It's amazing to think that we're still making such, like, fundamental discoveries about the sun, even though it's, been there all along. What other mysteries about the sun's long-term activity are scientists trying to uncover?
Well, one of the big questions is how the sun's activity is varied over time. We know it goes through these cycles, but are there, like, longer-term patterns, maybe spanning, thousands or even millions of years? Understanding those patterns could really help us predict future changes in the sun's behavior and, how those changes might impact the Earth's climate and the environment.
Now that you mention it, I have heard that some scientists believe there could be a link between solar activity and, long-term climate change here on Earth. Is that something that researchers are looking into?
Yeah, that's a really interesting question, and it is something that scientists are actively studying. It's pretty fascinating to think that these tiny little solar vortices, right, millions of miles away, could actually hold clues not only to understanding the sun's behavior, but also, like, the history and future of our own planet.
Yeah, it really highlights how interconnected we are with our star. The sun's influence, it extends far beyond just, like, providing light and warmth, right?
Right.
It shapes our environment in ways we're really only just beginning to understand.
And it seems like we are at a really exciting time right now in solar science with, new discoveries and missions like the Solar Orbiter, pushing the boundaries of our knowledge. Absolutely.
Yeah.
We're living in a golden age of solar research, with these advanced telescopes, computer models, spacecraft. We're gaining insights into the sun that would have been unimaginable just a few decades ago.
It makes you wonder, what other secrets the sun is holding, just, like, waiting for us to uncover them. So as we wrap up our deep dive into the world of solar vortices, what is, like, the one key takeaway you'd like our listeners to remember?
I think, the biggest takeaway is that even the most familiar objects in our sky, like the sun, are still full of surprises.
Right.
And the surprises can have, like, really profound implications for our understanding of the universe and our place within it.
That is a great point. We often take the sun for granted, but it really is this powerful and complex force that shapes our world in countless ways.
Exactly. So I encourage everyone to, keep looking up, keep asking questions, never lose your sense of wonder about the cosmos.
I couldn't have said it better myself. And for all you deep divers out there, we hope you enjoyed this exploration of solar vortices. Until next time, keep those questions coming and stay curious.